Good morning, everyone, and thank you for joining us for today's webinar. My name is Jean-Pierre Picard, Product Marketing Manager at CM Labs, and I'm going to be your host today. With me on the line is Marc-Alexandre Vézina, Product Manager for Vortex Software Solution. He'll be handling the live demo portion we'll have during this webinar. Today's topic is Vortex Software Solution 6.7, which was launched a week ago. Now, today's presentation is split in a few sections. We're going to start by doing a real quick recap of recent releases, just to position the new features in Vortex 6.7 in light of where Vortex is going. Then we're going to do a deep dive into Vortex 6.7's improvements, and we're going to do live demo portions mingled through to showcase some of the key new features. And then we'll finish by a live Q&A. Now, if at any point during the presentation you wish to send us questions, do go ahead and use the right-hand side questions box of the GoToWebinar interface. If you have issues with audio or video, we'll do our best to help you as well. If you wish to download today's presentation materials, you can do it in the Handouts panel. Today's presentation is being recorded, and we will send you a copy once the webinar is over. All right, so during today's presentation, we'll show you how Vortex 6.7 allows you to apply new textures on new channels to create better materials, better scenes, and how Vortex 6.7 allows you to address some of the challenges that were present in previous Vortex 6 release. We'll also talk about the new features that makes deployment of custom simulators a lot more efficient in Vortex 6.7. So we're going to go through this with a mix of slides and live demo sections. For those of you who are not as familiar with Vortex, Vortex is CM Labs' real-time visualization and simulation platform. It's used worldwide for virtual prototyping, so that is validating the performance of new product design, typically in off-highway equipment. It's also used extensively for operator training in a lot of industries, such as crane operation, heavy equipment operation, and offshore. And it's also used for operational planning, such as mission planning or heavy lift planning. Now, during today's presentation, we'll be using one of Vortex desktop applications, the Vortex editors, for our demos. The Vortex editor is the application that is used to create, validate, and deploy Vortex simulations. It includes also a built-in desktop simulation environment, so it's perfect for validating your simulations before you deploy them on a distributed system. All right, so if we take a quick look back at recent releases. Now, Vortex 6.5, which was released about a year ago, included features that worked towards three main themes. First, it was to simplify optimization and troubleshooting. And Vortex 6.5 saw the launch of the Profiler tool in both the editor and the player. This provided you with a deep inside view on how much time each resource in your simulation took to load. Now, this is great to identify areas where you can improve during a simulation that's not performing as expected. Vortex 6.5 also rolled out cascaded shadow maps, which really made shadows in Vortex a lot more realistic, a lot smoother. It also introduced water surface reflections in Vortex Marine. And it included a group of enhancements to the dynamics, especially on the vehicle side and on the cables system side. Vortex 6.6, which was launched earlier this year, improved performance in a significant way by adding the capability to instance identical assets. So that means that you only have to load each asset once to memory, even if you use it multiple times. Now, as you'll see today, this is leveraged as well in the new Vortex 6.7 multi-texturing capabilities. This was a fundamental building block. Vortex 6.6 also provided significant enhancement to the graphical pipeline. It saw the introduction of the graphics gallery, a new document type that provided you with controls over a few channels and the model layout for your mechanisms. And it also included the new CAD Optimizer add-on. The CAD Optimizer add-on allows you to import CAD models in Vortex and use them as the basis of your mechanisms. Vortex 6.6 also saw the addition of DAE support, so you can create mechanisms from Collada files. And finally, we also saw the support for speed tree assets. Vortex 6.6 also included a lot of enhancements to earthwork systems, such as compaction layers, to Vortex Cable and Vortex Marine. Now, we continue on this series of improvements with Vortex 6.7. Vortex 6.7 again sees significant improvement to visuals. We're going to be showing you how we are leveraging investments done in Vortex 6.6 to enable multi-texturing and to add new anti-aliasing methods in Vortex. Vortex 6.7 also saw the rollout of new lighting engine, which will provide more realistic shadows. Vortex 6.7 also provides a lot of tools that makes deployment a lot easier, with a new setup interface, which enables the creation of Vortex configuration files using a graphical user interface, a new display management tool, and the launch of VIEWPOINT extensions. And finally, Vortex 6.7 sees improvements in vehicles dynamics with the addition of the ability to link files for the torque converter and to improve the modeling of automatic transmissions. All right, so we're going to jump into improved visuals, which is one of the three main themes of Vortex 6.7, and it's also the one where we'll be spending most of the time today because we have a lot to show you. So in Vortex 6.6, I already mentioned we've launched a graphic gallery. Graphic gallery was a new document type in the Vortex editor that provided you with control over graphics materials and model hierarchy. It allowed you to modify the textures you had in the available channels. In Vortex 6.6, you had 4 channels. It also allowed you to rearrange the different nodes you have on your model. So this was a good first step to provide you some manner of control over your model's graphic materials, but it was really fairly limited. There was a few key limitations. First is that you had a single texture layer per channel, which means that you could not layer multiple textures on top of one another. You also had access to a single UV set per texture. So if you wanted to reuse a texture, you could not use different UV sets, which meant you had to load it twice. You could not apply masks. Obviously, if you can only apply a single texture layer, then masks are not as useful, but still, it means that you could not use textures and decide which part were displayed and which part were hidden. And you also had access to a limited number of channels. Now, the net result of this was that you very often ended up with visible tiling on large surfaces. You also had to use larger graphic files than is optimal, which resulted in limited performance. So it was a trade-off between tiling, graphic file size, and graphics quality. You also had a limited capacity to fine-tune graphics in the graphic gallery, even though it was a step up from previous releases. And finally, the creation process was not aligned with what 3D artists are used to. Now, if we're talking about visible tiling, just so everybody is clear what we're talking about, because we're going to show you how you can address this in our live demo later. Visible tiling is because it happens when you apply a texture on a surface, but that surface is large. So you either have to apply a texture a single time to it, and it will be a massive texture file, which is not a possibility, or you have to tile it. So tiling it means you will have repeating elements. You could have seams. Sometimes they're not as visible as the repetition though, such as in the offshore sample scene. If you look at the subsea floor, you can see that there is a lot of repetition of details. You don't see exactly where the texture is joined, but you can see that the texture is tiled a lot of times. So, but this is a trade-off because from up close, you know, you can still see the tiling, but between that and having an extremely large texture file, which would slow down your simulation, then sometimes you didn't really have a choice. So to address visible tiling, sometimes you have to use large graphic files, and this can be shown in the excavator sample. Now, if you want to achieve the level of details you need from the operator's point of view, you had to have a minimum texture file that was really based on the smallest element of focus. In the case of the excavator scene, your operator will be fairly close to the ground in his excavator, and you will see details such as gravel, such as the different section of earth that are fairly close from his point of view. So you had to have a big texture file that you can tile multiple times. So you can see here that it's actually fairly seamless. You don't see that much repetition. The reason is the texture is actually tiled 4 times. To achieve that, though, we had to use a very heavy file. We had to use a 4K texture, which took 64 megabytes of memory, which is significant comparing to what would be ideal. Now, I also mentioned you had a limited capacity to fine-tune graphics in Vortex, which meant that the modeling process required more back and forth in external files, in external software solutions than is ideal. If you had changes to apply, you had to get back to your 3D artist who would work on the model in an external software, and then you had to re-report it. So that is really not optimal. So the solution to this is the introduction of multi-texturing to Vortex. Multi-texturing is the capacity to apply multiple layers of textures and masks on top of each other to create natural-looking graphic materials. Now, those graphic materials will be achieved with smaller files than they have been in previous version of Vortex. If we look at how it works, in previous releases you apply the first texture and that was what would be wrapped on your model. Now you can apply a second texture on top of the first texture. But if you apply it like this, like in the graphic, then you will only be seeing the second texture because it's covering entirely your first texture. So to be able to compose graphic materials with them, you can apply texture masks to your textures. So in this case, it would merge the top layer with the bottom layer based on which areas you decide to let show through and which areas will be displayed from texture 2. This will allow you to layer things such as ground and grass without having a dedicated texture for ground and grass, for example. Multi-texturing in Vortex 6.7 is applied at the graphic material level. So you can apply up to 16 layers, 16 texture layers per materials, and you have access now to 6 channels. Each of those textures have their own mask, and you can apply their own factors to it. So you get to create a very wide range of natural-looking graphic materials, from rocks to ground to totally synthetic materials such as a chicken wire fence here. We're going to look at how you can create these in a few minutes. But before we do that, I'd just like to go back to the channels. So what are the channels available with Vortex? So in Vortex 6.6, you had access to 4 channels. Emission, which provides self-lighting to your models, diffuse, normal, and specular maps. In Vortex 6.7, we've moved to 6 channels. So one of them, albedo, replaces diffuse as the base texture layer. And 2 of them, occlusion and gloss, are new channels. So what are those new channels that are available, and how do they impact model? So to see what they do as far as modifying graphic materials, we're going to look at them with our new buoy sample. The first channel, the albedo channel, is considered your base channel. It's the one that provides the base color, base texture to your model. So if we look at our buoy here with a base albedo color of white, you can see that it wraps our model in a uniform coat of white paint. Now, the ambient lighting will create shadows on it, but it's all the exact same white. There is no detail, there is no volume to our model, but that provides a starting point. If we change the albedo color to red, then we would wrap it all around in a uniform coat of red. And again, it's only modified by the ambient lighting and the shadows it creates. More typically on the albedo channel, you will be applying a base texture, such as this one here we have on the buoy. So it provides details, but you can tell that it still looks fairly flat, but this is the starting point. And then you will be applying your other channels to achieve better results. You will be able to provide volume with the normal map, for example, and define shininess with the specular channel. The second new channel available in Vortex 6.7 is the occlusion channel. The occlusion channel provides your model with self-shadows. It adds volume with shadows that are not created by the ambient light sources. So it's not computed in real time. It does not take as much of a toll on resources. Actually, it takes almost no toll on resources because it's a static element. But it provides a layer of sophistication to your model. So this is a close-up of our buoy model without an occlusion map. You can see that the edges here are all too sharply defined. Typically, you're going to have some layers of shadows here, absence of lights, basically because lights doesn't get there. If we applied an occlusion map, then we would be replicating this effect that we see in real world. And you can see that this provides a lot more volume to our model. It makes it look a lot more realistic, even without any colors here, you can see a big difference. Now if we compare both of them, one of them gives you a much better idea of the depth of your model and the edges. Now the final new channel available in Vortex 6.7 is gloss channel. So the gloss channel defines how light that is shined on your model is spread on it. So a lower gloss value will spread the light more evenly on the surface, whereas a higher gloss value will reflect light in a more precise way, a more pinpointed way. This is typically used in conjunction with the specular channel, which defines how much light your model actually reflects. All right, so to look at how to apply, how to create graphic materials with multiple layers and how to use these to address the challenges I mentioned earlier, we're going to switch the presentation to Marc-Alexandre Vizna, who will be doing our first live demo of the day. Marc-Alexandre.
Thank you, GP. So to start with, we're going to look at how we apply texture to a model. So I've opened a graphic gallery using the new button here. And now I have a graphic gallery. I'm going to import a model using the 3D button up here. And I'm selecting the buoy, confirming. And now I've got my buoy model in my main 3D viewport. Now normally the texture and the graphic material will come with your model if the graphic artist include them. In this case we've kept them separate so that you can show how they're applied to the model. On your left in the Explorer panel in the graphic gallery you've got the nodes which show the material and the geometry, and a folder for the geometry and a folder for the graphic material. Now this basic graphic material, we're going to set it to white as you can see better. So now the buoy has no texture, it's just purely the 3D model. If we look at our graphic material, we've got the number of channels that are available, the emission, the occlusion, albedo, specular, gloss, and the normal. And we have layers that we can apply, we can add to them. So in this case, we've got an albedo layer already set up, a specular, and a gloss. Using the plus and minus button, you can add layer as you need them. And in this case, we just want to put a basic texture on it. So we're going to go use the add texture button here. And we're going to select the texture that we need, in this case the albedo, and it's being imported. And as you can see, the albedo is just like a watercolor. It's got no shadow, no definition, it just purely adds the color to the model. So going back to our graphic material, we're selecting the texture spot, taking the texture, confirming, and now our buoy is colored. It doesn't have any shadow or detail, it just has the color. So we're going to keep going and we're going to add more texture to it. In this case, we're going to use the specular and the gloss, and by using control, I'm multi-selecting them, and you can import them both at once. We're going back to our material. And we're selecting specular. You'll notice that we've named the texture using the channel and the resolution, in this case 1K, so 1024 pixel by 1024 pixel. It helps a lot find what is what in a large model. So we don't see much because the texture is currently off, so we're just going to pull it back on, and already you can see some shininess being applied to the model. But it's still fairly flat, so we're going to want to add a normal channel to it to give it some 3D effect. So I've used the plus, added a normal, and then we're going to select the normal texture, and we're being loaded. There we go. So now we have our normal texture, and we're going to want to drop it into the proper spot like this, and right away you can see that there's a more 3D effect to the model as the normal change the way the light is reflected, and we can play around with the factor to make it more effective or less effective. So let's put it back to 1. It's still fairly flat, so we want to add an ambient occlusion layer to fill in the absence of light in the corner of the model. So for that, we go back up, we create an occlusion layer like this, and we go get the ambient occlusion texture, which is right here. So you can see the shadow in the model. So we're going to go and we're going to drop it into the proper channel. It doesn't quite work. And why is that? It's because the ambient occlusion texture is on a different UV set. What this means is that the model was unfolded differently. Reason for that is that we want to hide the seam. If we were to do this, the seam would be showing on the cylinder. We want to hide them in the crease. So what we're going to do is just click on the little orange arrow, which brings us directly to our texture, and we're going to change the UV set here to 1, and that puts the texture where it should be. The new Vortex 6.7 supports 4 different UV sets. The UV set must be defined by the graphic artist that prepares the 3D model. It's not something that you can change in Vortex itself, but you can access it here. And going back to the model, we're going to turn on the sunlight, and now we can see that the model is a lot more realistic than we had before. We can also turn on environment reflection to get additional reflection from the sky dome or the skybox if you've set them up. So as you can see, it creates a much nicer model. We haven't put an emission texture in the model, but we could have made one for the light on top if we wanted it to shine during a night scenario. Moving on to our offshore terrain, so the underground terrain that, the undersea terrain, sorry, that GP showed you earlier had very bad tiling. Here, we've changed it to something that's also tiled, but it's much less apparent. What we want to do is have something that looks nice when we see it from the proper perspective. So instead of seeing the tiling, we can see a little wave, the little dune effect in the water, some spotting, and it was very easy to do with just a few texture. So what we did is we used the same texture here, and here is the same texture. It's just the UV angle is different and the tiling is different. What this does is that it hides the seam between the textures, and it allows us to use a small texture, tile it often, but still create a unified appearance. To make it nicer, we've added a mask on top of it to create that sort of model effect. And we've also added a normal to create that sandy dune, the wavy effect inside the dune. So that creates a much better undersea environment. We can also use this above ground. I remember the construction site that GP showed you a bit earlier. Now this was very big. The problem is that when you want to scroll in from an excavator perspective, you need some definition in the rock and in the ground. So to create this and still reduce the size of the model, so we're going to go into the graphic material and the pit middle texture. And how this was accomplished is that we've used a series of mud and normal mixed together with different tiling, and then we've placed them at different angle. You can see that the UV tiling, instead of being 4, it's 10. We've repeated more often, and the angle is also offside. So what this does is that it changes the way it's layered, and it hides the seam. So we can have a much smaller texture and still have a nice result. We've also added an ambient occlusion layer to create the shadow effect on the dune here at very low cost. The multi-texture can also be used to create some interesting effect. Now this is the light armored vehicle that comes with the Vortex sample. It's already a nice vehicle. We can bump it up a bit more with the new ambient occlusion layer. So we can go and get an ambient occlusion. And now it creates a model that has self-shadow. So now the light doesn't reach under the wheel well. There's a shadow under the turret, and the model looks a lot more realistic. And you can also use the multi-texture feature to create some interesting effect. For example, here we've added a dirt texture under the main no dirt, the main clean appearance of the model. And by selecting this, by playing around with the alpha channel, which is the transparency, we can dirty up the model. It's still the same, it's just a different texture that's being applied. And these channels are accessible by a script. Therefore, it would be possible to have a script that makes you react to the environment. So for example, my LAV is going through a mud puddle, and the script changes the alpha channel value to dirty up the vehicle as we need. Now, just to show you what can be done with in the more extreme case, this is the forklift that's going to be in the sample Vortex 6.7. You'll see, if you look at the right, that we've used all 16 texture spots to create the texture. So it's an example of a very complex graphic material. But what it does is that it creates a vehicle that's very realistic and reacts correctly to the light. Back to you, GP.
Thank you, Marc-Alexandre. So, multi-texturing is one of the main new elements of Vortex 6.7, but I've already mentioned that we have a few other things that contribute to improve visuals in Vortex. So, the second set of features is the addition of two new anti-aliasing methods. The first one, fast proximate anti-aliasing, is an extremely efficient pixel shader program, and it provides smoother edges, including on alpha blended textures, and it's done as a shader program, so it's extremely efficient. The second one is called Enhanced Subpixel Morphological Anti-Aliasing, or SMAA, and this one is a GPU-based post-processing filtering technique. Now, it will provide smoother edges than with the FXAA, but it will have a slightly greater cost of performance. It's still very efficient, but it will which one you use will depend on your simulation and your available resources. Now, if we look at exactly what that looked like in the simulation, if we take our forklift sample seen here, and we're going to zoom in on one of the window here. Now, you can see that without anti-aliasing, we have significant jagged edge here, and we can see it on the frames. Now, if we were to apply FXA, it smooths it out to a great extent already. But you can still see, there's some jagged edges on it, so if we have the resources available, we can use SMAA, which will smooth it out even further with a slightly greater cost to performance. So again, which one you use depends on available resources and your simulation itself. Setting it up is extremely easy. In the editor, you simply go under Tool Options, and you will have a new section here that allows you to select which anti-aliasing method you want to use. Now, if you want to set it up in the player, you add it as an extension to your Vortex configuration file. And you can do this using the new setup interface that we'll look at in a moment. Now, once you add it to a rendering node, it will apply to that node. So it means that you could modify which anti-aliasing method you use depending on the node that you select. The final point that improves visuals in Vortex 7 is a change to the lighting engine, and we're moving something that's closer to physical-based rendering for our lighting. It's not actual physical-based rendering, but it's a lot closer. Creates more realistic exposure and shadow. So this is our previous sample in Vortex 6.6, the mobile crane sample. And you can see that the concrete blocks are overexposed, and the trees, there is no shadows within the trees. It's all a bit washed out compared to what it would be in reality. It's a bit too exposed to light. So in 6.7, you can see that the lighting distribution is a lot more realistic. Your concrete blocks do not reflect as much light because concrete is not a material that should be completely white under sunlight. And there is more shadows within the trees. So it's all a lot more immersive than it was before. All right. So moving on to our second section, which is the new features that simplify the deployment of Vortex simulators. The main change in Vortex 6.7 is the launch of the new Application Setup Interface. The Application Setup Interface is a new document type in Vortex Editor that takes one of the last elements that we're still requiring code writing and moves it into the Vortex Editor. So throughout Vortex 6 releases, you've probably noticed that more and more tasks can be done in the Vortex Editor, and our goal is to allow the complete creation of a Vortex simulator in the Vortex Editor. And this change it makes one of the last few holdouts moved into the editor. So the new application setup interface is extremely user-friendly. It includes a visual network hierarchy which shows your master and your slaves and which modules and extensions are assigned to them. It also provides templates that allow you to quickly create one or two display nodes, so you can easily build your basic network hierarchy using those templates. It includes a very useful display configuration visualizer. Now, This will provide you with a visual representation of your monitors, their size, their angle, and how they're positioned in reference to your user's point of view. And you have a graphical setup UI that allows you to set up your different parameters using point-and-click interface instead of having to write custom code. Now, the new application setup interface really makes it easy to create all manners of simulators. Whether you're looking at a 3-screen simulator or a 5-screen one, for example, all you need are real-world dimension and angles of your hardware, which are easier to obtain. And then you simply enter those and you will get a representation of what your simulator will look like. Now this works in conjunction with the new viewpoint extension. So if we look here on the screen, you can see that we have our operator's viewpoint shown in the display visualizer. Now the new viewpoint extension is an extension you add to your mechanism or scene as a new camera type, basically. And it defines the location of your simulation participant. So if it's a trainee or if it's a human operator that's going to be testing your designs. This defines the location it is, and it simplifies multi-channel simulator configuration because instead of having to create viewports for every single display, now you create a viewpoint extension and you link this in your configuration file. So this will save a good amount of time. So we're going to go back to Marc-Alexandre, who will create a simple configuration file for us in the editor. Marc-Alexandre.
Thank you, GP. So what I've done here is that I went to the new and I've selected the new setup file, and it gives me the usual interface with the Explorer window on the left and a property panel on the right and a viewport that's empty at this time in the middle. Up in the toolbar is a little bit different for the setup editor. First, you've got the ability to add extensions, texture, Y texture. You can use them for loading screen, for example. Node, which are the computer nodes that are going to create your network. Seats, which is the user seat, much like a role in the scene or mechanism. Module, you can insert a 3D reference model if you need, for example, to you have an entire cabin, for example, you can insert it and use it as a reference or as a graphic gallery. And lastly, we've got a couple of presets that are already included here, including a standalone for the Vortex player, for example. In this case, we're going to use the masters with dynamics, so I click on it. And now the computer automatically inserted a node for the master, as well as the required network process and a Vortex human support. If I open the master, there's already a dynamic engine module in there, the recorder, the keyframe module, and the earthwork system. We've got no display here yet. So what I'm going to do, I'm going to go and add a slave node with 2 windows. And what it does is that it creates in the main viewport a 3D simulation of what my my slave looks like. So we've got a first display, second display, the slave itself, the graphic engine, the data monitor, a basic joystick, audio, and metric manager. Now, all of these can be added through the toolbar up here. They can also be removed if you don't need the audio in your configuration because you got no speakers. For example, you can remove the audio module. Now, we're going to want to resize our display. So let's just add this. So we've got our placement here. We've got the physical position and the orientation. These are real physical value that you can measure on the floor and adjust as you need. So let's try and resize a screen. So we're going to make it a bit larger. There we go. So we got a bigger screen. And we can change the physical position. So bring it closer, move it to the side like this. So here we're going to put 0.4, for example, and we're going to move it a bit. And you can change the physical orientation as well, like this. So we're going to put it at like 10 degree. And then I can go back and redo the exact same operation on my second display. Like this. There we go. And then we're going to move it a bit like this, and then we're going to change the orientation. And it's not quite accurate, but I think you get the idea of what it looks like. And once we save this, it's going to save it as a VXC file, which is the configuration file that you would normally write by hand in order to configure your simulator network. This can be used for something that's a lot more complex. This is going to be familiar with those of you who've seen the Vortex 5 screen simulator in action with a separate touchscreen LMI panel. This is actually just a work in progress. It's not the full configuration file. You can see that there's lots of nodes set up, some for the console of the instructor, the operator, the trainer, a node just to manage the audio, a node to manage the CAN bus device, a node to display the various, to handle the various display, in this case a network slave, graphic module, an extension to display a loading image that's going to be loaded as a separate texture, and so on. And so you assemble this just like you would a modular brick toy until you get the full configuration that you need, and then you save it and you're ready to go. These files can be reused between simulators. So if you have set up a complete 5-screen simulator, it's possible to change it. For example, select these and just remove module, and then you have a tree simulator set up all ready to go. And as GP mentioned, this human guy here is our viewpoint, user viewpoint, and it's linked to the viewpoint extension that's been added and that you can insert in your mechanism and your scene. So in the end, this makes it a lot easier to set up your simulator, a lot faster, and a lot more accurate as well. Back to you, GP.
Thank you, Marc-Alexandre. All right, so we're getting into the home stretch of today's webinar. We're going to talk about vehicle improvements, which is the third main focus of this release. So vehicle system improvements are mostly focused on making it easier to model automatic transmission and also manage the logic behind it. The first change is that you can now link CTR tables and lambda tables for your torque converter. So previously you had to hard code them, which made updating them extremely time consuming. By being able to link external CSV files, then you can simply export your tables from a engineering simulation tool and link them to your models. So this makes it a lot easier to keep them up to date. We've also added the ability to configure transition time when your transmission switches gear, so it's a more accurate representation of your vehicle's behavior. As you know, when you're changing gear, there is a certain decreased in performance while you ramp up the RPM, so this will more realistically simulate that. We've also made it possible to restrict the gear ranges used by the vehicle in the transmission logic, allowing you, for example, to limit gears from drive to true 4 by selecting D2, D4. This is useful to simulate faults or to simulate advanced control systems. And finally, we've made it possible to set the maximum torque used when locking the differential. So it sets an overall maximum torque for your vehicle instead of providing infinite total force and to each wheel. This will provide a more realistic behavior when using the differential lock. There are a few other miscellaneous improvements in Vortex 6.7. Mainly, Vortex libraries are now compatible with the latest releases of CentOS and Ubuntu and Red Hat Enterprise. So this is great for those of you who are working in Linux environments. It will allow you to use Vortex with up-to-date operating systems. We've also added a new generic bucket tool. In previous releases of Vortex, when you're creating a earth-moving bucket, you had to use a bucket that was shaped like an excavator's, which made it hard to create buckets for something like a wheel loader here, because the size of the bucket is definitely not the same. It's not the same shape, it's not the same width. The new generic bucket tool makes it very easy to create custom buckets by simply allowing you to map the capabilities of bucket to an existing parts collision geometries. And then that collision geometry will become a bucket and will track the amount of soil that is contained within it. Finally, we've also made it possible to use graphics galleries as terrain. So this not only gives you full access to the multi-texturing capabilities that we've shown earlier, and it makes it a lot easier to create good-looking scenes with smaller texture files, but it also allows you to edit nodes on your terrain directly in the Vortex editor. For example, adding additional houses to a scene, or moving or removing lampposts. So this provides you with more capabilities to fine-tune your simulation directly in Vortex when you realize that maybe you wanted to place a camera or a viewpoint there. And it's a lot more efficient than going back to a 3D artist and working on the scene in a third-party solution. All right, so if we look at documentation, the Vortex includes, as usual, the user guide, an updated samples guide. Each sample were updated for Vortex 6.7, updated product specification and release notes. The validation and verification guide has been updated, and we also have a new theory guide that provides an in-depth look at the formulas used in the dynamic simulation portion of Vortex. So this is really, if you are looking at it from an engineering perspective, it's a great document to look at exactly how Vortex simulates specific elements of your scenario. And sometime this summer, we'll also be rolling out a new 3D artist guideline that will provide with a good set of guidelines into creating good-looking Vortex simulations, such as the recommended texture size per meter, for example. Sample scenes, as I mentioned, were updated, but there are no new scenes. The defense vehicle was updated with new visuals. The excavator and dump truck scenario was updated with the addition of a new concrete pipe in the diggable area, as well as updated visuals. The EOD scene was also updated to make use of multi-texturing. The forklift in warehouse scene was completely revamped, was redone from the ground up with new models, with significantly updated textures. You'll see, well, as Marc-Alexandre mentioned, it's a very complex forklift model with the maximum number of texture layers, and it will show when you open it up. The forestry forwarder has been updated as well. The terrain was significantly modified to take advantage of the multi-texturing capabilities. The mobile crane saw slight updates as well. The offshore sample scene was modified, especially as it regards to the subsea seabed. And the engineering parkour was modified to take use of multi-texturing. Now, we also have a new materials samples, which is a graphic gallery with a lot of new material on there that are already created. So you have textures layered to show you exactly how you can create different types of materials. It's not a scene per se, but it is useful to then apply to scenes and to mechanisms. All right, so if we look at what we've looked at today, Vortex 6.7 now provides you with the ability to create more engaging simulations that perform better with multi-texturing support and more efficient anti-aliasing method. But they also provide you with a more efficient creation pipeline and the ability to create custom simulators a lot more efficiently than before. So we feel it is a significant step into making the creation of simulations not only more efficient, but making them more engaging. Now, we're going to move on to the question side. For those of you who are leaving us, again, thank you for joining us today. We hope that you learned what you were looking for regarding Vortex 6.7. We will be taking questions, but the webinar was recorded as usual, and we'll be sending you a copy somewhere around the end of this week. All right, thank you.